Hi everyone. In today's lesson, we will talk about estimating derivatives. First, we'll be using tables. So using the table below, estimate f prime of 3 using appropriate units. So notice the table is about x and f of x, which is our original function, and they're asking us to find the derivative at 3. So we have to remember that the derivative is also the same as the instantaneous rate of change. So we can't use the limit definition or the alternative definition of the derivative because we're not given an equation, we're just giving a table. So notice the directions say the word estimate. So because it says estimate, we can find the average rate of change using the values that are the closest. So would we agree that the x value of 3 would be somewhere here? So if we did the average rate of change, which is the slope, that we could use to estimate f prime of 3. So we're going to take the 2 and the 4, since they're the closest ones, and we're going to do the average rate of change with that. Remember, average rate of change is change in y over change in x. So the y values here would be 10 minus 3, and the x values would be 4 minus 2. So the thing, though, that we have to look out for in this is that the directions say using appropriate units. So when we subtract the 10 minus 3, that came from miles, so we're going to put miles here. And then the 4 minus 2 came from hours, so hours. So 10 minus 3 is 7 miles, and 4 minus 2 is 2 hours. So 7 divided by 2 is 3.5. So we can say 3.5 miles per hour would be the best estimate for the derivative. Okay, let's try another example. So using the table below, estimate W prime of 100. So same scenario. This means the instantaneous rate of change at x equals 100. However, we can't necessarily use that because we can't find that because I don't have an equation. So we're going to use the average rate of change for the ones that are closest. So I have 80 and 120 that are pretty close to 100. So we're going to find the average rate of change between those values, which is change in y over change in x. So the y values are 500 minus 700, and that is in gallons per second. So gallons per second all over the x values, 120 minus 80. And that value is in seconds. So 500 minus 700 is negative 200 gallons per second all over 120 minus 80, which is 40 seconds. So we can divide the negative 200 and the 40, and that will give us negative 5. And to figure out what the gallons per second is, you could do a little keep change flip with the units. So you could put this seconds over 1, do it on the side here. You could say gallons per second, keep that, change the division to multiplication, and then flip the other one. So then you're just multiplying straight across. Gallons times 1 is gallons. Seconds times seconds is actually seconds squared. So you can say it's negative 5 gallons per second squared. So that would be estimating the derivative at 100 using appropriate units. Okay, before we can move on to the back, we actually have to talk about a couple of things with derivative notations. So these are the notations on this side that we are used to: f of x, f prime of x, and evaluate using f prime of a. So a nice simple example of that could be, so let's just say we have f of x equals x squared minus 2x. And I give you that the derivative function is 2x minus 2. And I ask you to evaluate f of 5. All you would do is plug 5 into the function. So 2 times 5, which is 10, minus 2 is 8. So you'd say f prime of 5 is 8. So there's another notation that we really haven't used often, is that if I give you the function instead of f of x, let's just say I give it to you in y equals. So we can write that over here. So let's just say I give you y equals x squared minus 2x. And I ask for the derivative. This time it would be written as dy over dx. All that means, it's the derivative of y with respect to x. So the bottom is with the respect to, meaning I'm taking the derivative with x's. So just I would tell you that the derivative is 2x minus 2. And if I want you to evaluate this derivative at x equals a, what I would do is I would write it as this, d dx. I want you to take the derivative of this function, x squared minus 2x, and I want you to evaluate it when x equals 5. Same thing as what I did over here when x equals 5, right? So I'm asking you to take the derivative of this and then plug in 5. So you would still have the derivative here, which is 2x minus 2, and you would still plug in 5. So 2x minus 2, and you plug in 5, and you get your 8. So it's the same thing. The notation is just a little different. So this d dx means take the derivative of this and then evaluate it and plug in 5. Okay, so how does this apply? Well, in example number 1 here, I'm saying use the calculator to estimate the derivative of this at x equals 2. Be sure to round appropriately and use proper notation. So be sure to round appropriately. What that means is something that I haven't really discussed yet, and I'm going to write this over here. On the AP exam will accept rounded answers to 3 decimal places. Now, like I said, rounded. Your answer can be rounded, or your answer can be unrounded. So the AP exam really doesn't care too much about rounding. It just cares that you go 3 decimal places. So when I ask you to use your calculator to estimate this derivative, I'm asking you to just go 3 decimal places. You can round if you want, and you don't have to round. You can leave your answer just in 3 decimal places. So the question here is asking us to use the calculator. Why? We don't know how to find the derivative of cosine of the square root of x. So we're going to follow these steps here. So take a minute, pause the video, and grab your calculator if you don't have it. And we're going to hit math first. Then we're going to go to choice 8. So you should see here choice 8 and deriv. This means evaluate a derivative. It's not going to give you the derivative equation. It's going to evaluate it for you. So this notation should appear on your screen after you hit that. So I'm going to go back up here and I'm going to start writing. So it says d something, and then it has a parenthesis, and it evaluates, and then there's some leftover space on the bottom. So you have to put the x in here. So it's d dx, that means the derivative with respect to x. And you're going to put this function in the parentheses, so cosine square root of x. And then we want to evaluate that. They tell you here at x equals 2. So all you're doing is typing that into the calculator just the way you see it. Take a minute, pause the video, and then hit resume when you're ready for the answer. Okay, so your calculator screen should read -0.34922, so on and so on. So I'm going to leave this at 3 decimal places, so the 9, so -0.349. No need to round here because the 2 is lower than 5. And so -0.349 is the appropriate answer. If you did not get this, that means your calculator was not in radian. Anytime you are using sine, cosine, or tangent, your calculator must be in radian mode. So if you did not get this number, please switch your calculator over to radian and then try one more time. Okay, example number 2, same thing. We're going to use the calculator to estimate the derivative of this. So clear out your calculator screen and hit resume when you're ready to start. Okay, so we have d dx, the derivative of ln of 5x plus 1, and I want to evaluate that at x equals 3. So take a minute, pause the video, type this into your calculator, and then hit resume when you're ready for the answer. Okay, so your calculator screen should read 0.312 2, 5, and then a couple zeros. So you go 3 decimal places. So your answers that would be accepted on the AP exam would be 0.312 or 0.313. Why? Because you look at the 5 and you can round that 2 up. So either answer is accepted, and that's totally fine. Okay, so example number 3, I'm actually going to leave for you guys for homework. I'm going to give you a couple of hints. First thing, they want the equation of a tangent line. Remember, that's y minus y1 equals mx minus x1. And in order to use this, we need a point, which we can use by plugging into the original equation, f of x, and we need a slope, which we can use for my derivative, f prime of x, right? So you might need to use the calculator to find the derivative because we don't know how to find this algebraically. And you may be able to find the point algebraically by simply plugging in. So I'm going to let you just at least try it. If you have trouble, that's okay, but at least give it a shot. And then we'll start class by going over this one tomorrow. All right, have a good night.